one of the ways to protect against the claim in case of an accident is that when we insulate the pipes that runs hot steam or gas steam, we make sure that the insulation are beyond the critical value or critical thickness. Because if it's not, then it will increase the resistance, the conductivity resistance in here, conduction resistance. Because we know that insulators, they reduce convection, but if it's not the right thickness, it might increase the conduction resistance. So what does the thickness depends on? It depends on the value of heat transfer coefficient, and also depends on H, the value for H. So if we can monitor that by knowing what exactly the critical radius, so we make sure that the radius of our thickness is beyond that to increase the the heat loss during the process. And when we minimize the heat loss, then there might be no issues with running the gas steam inside. There will be no overheating, and there will be no heat pop issues in the future.
Okay, hello, my name is Hidayah. So, uh, for my group, we choose question number 3, which is required us to explain about the safety, outline of the safety problems that need for the system. Okay, uh, we've been searching, and then there are a few examples that are similar to the question, and they said that the system really take note about the radius which is denoted by R, K which is the thermal conductivity, H denoted by heat transfer coefficient. So the question gives us about the velocity and the heat transfer coefficient. So the three element is very important for the system. So I will explain about the K element, which is the thermal conductivity element. Okay, so for thermal conductivity, the definition is which is a measure of ability of a material to transfer a heat. For example, if two molecules collide, an energy will transfer from the hot to the cold molecule occurs, and there will be a cumulative effect from all collision between the net flux for the both of the body. So we call this kind of transfer is thermal conductivity. So regarding to the question, thermal conductivity does not vary appreciably with the temperature. That's why the question didn't give us the specific temperature, and we can see here. Okay, this is the design parameters that need for the certain for not for certain but all of the system. So we need a diameter, temperature, insulation, electrical. Okay, for my part, I will explain about the thermal conductivity. So for the thermal conductivity, we need, because they said that it does not vary to the temperature. So we need to use low ambient temperatures for the startup temperature, as it will give us a maximum circuit length and circuit breaker sizing for a given application. So as we can see here, okay, wait. Okay. Okay, as you can see here, when the heat loss of the insulated pipes exceeds the output of the desired cable, consideration should be given to. Okay, first we need to use multiple passes of cable. Why we use multiple passes of cable? Because multiple passes of cable will give the heat more efficient. For example, if we have a one cable and many cable, so one cable we get many forces, many pressure. So if multiple passes of cable, it will give us a very high efficiency. So when we use multiple passes of cable, the temperature or the thermal conductivity will be increased. Okay, we can see here lower K factor. Lower K is the thermal conductivity, as I said earlier. So when there is a lower conductivity, lower thermal conductivity, so it will decrease the heat loss. When we decrease the heat loss, the system will become more efficient and become more safety. So we need to use multiple passes of cable, switching to the higher power output cable, and we need to have insulation thickness. Insulation thickness play an important role in order to decrease the heat loss and in order to lower the thermal conductivity. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nazrin binti Abdul Rashid. So today I'm going to talk about the safety outline that need to be addressed to the insurance company, which is the temperature raising in the system that might go beyond the limit in the system pipeline. So what we can do is that we can put the temperature indicator in the pipeline so it can show when the temperature goes high, so the workers can take precaution steps, which is to reduce the temperature by put cooler or put another substance to reduce the temperature. My second point is that the pipeline failure that might discharge harmful substance to the human health and environment. This can be calculated by the using pipeline impact radius, PIR. Basically, the formula is being derived from the pipeline property, which is diameter and the pressure, where we can see from the formula R stand for impact radius in feet, which is radius of circle within the potential failure of a pipeline that could have significant impact on people or property. So by this, we can see that it is really important for us to choose the best diameter of pipe so that it can reduce the amount of impact radius. The last one is that rate of pipeline corrosion due to the chemical reaction happen in the pipeline and the environment factors, which is we can use a combination of coating pipeline and a cathodic protection system so that we can reduce the amount of corrosion. So then we can reduce the amount of any potential accident that can happen. So we can increase the safety. That's all for me. Thank you.